Simultaneous equations by elimination 4. Simultaneous equations are equations where we find out what two letters are equal to. Here I have simultaneous equations 6a plus 2b is 22, 2a plus b is 8. Now the first thing I notice is that none of the numbers in front of the letters are the same. I've got 6a on top and 2a on the bottom, 2b on top and 1b on the bottom. So if I try and add or take away, none of those letters will disappear. The first thing I need to do is multiply one of the equations so that the letters are the same. I notice that I've got 2b on top, and if I multiply the whole of the second equation by 2, I'll have 2b on the bottom as well. Write down the first equation again, and I'm going to multiply the whole of the second equation by 2. 2a times 2 is 4a, b times 2 is 2b, 8 times 2 is 16. So now I've got 2b on top and 2b on the bottom. Now because these two things are the same, I'm going to take away. 6a take away 4a is 2a, 2b take away 2b is nothing, 22 take away 16 is 6. So now I've not got a normal equation. I want to know what 1a is, so divide both sides by 2. And I find out that 1a is 3. Now I'm going to have to find out what b is now as well. So I'm going to use the first original equation, 6a plus 2b is 22. I'm going to write that down and then substitute in a is 3. And that will help me find out what b is. So write down the original equation, 6a plus 2b is 22. Remember that a is 3, so 6 times 3 is 18, plus 2b is 22. This is just a normal equation now. So I take away 18 from both sides, and I end up with 2b equals 4. But I want to know what 1b is. So divide both sides by 2, and I end up with 1b is 2. So my final answer for this simultaneous equation is a is 3, b is 2. (3c minus d is 11, 2c plus 3d is 11 as well. What does c and d equal? Again I notice that the numbers in front of the letters aren't the same. I've got 3c on top and 2c on the bottom. I've got minus 1d on top and 3d on the bottom. The first thing I need to do is multiply one of these equations so that the numbers in front of the letters are the same. I've decided I'm going to make the d's the same, so I need to multiply the whole of the top line by 3. 3c times 3 is 9c, minus 1d times 3 is minus 3d, 11 times 3 is 33. Just rewrite the second equation again, and now I've got what I need. I've got minus 3d on top and plus 3d on the bottom. Now because they're different, I'm going to add them together. Add them together, 9c plus 2c is 11c, minus 3d plus 3d is nothing, 33 plus 11 is 44. So 11c is 44. Divide both sides by 11 to find out 1c. 11c divided by 11 is c. 44 divided by 11 is 4. So 1c is 4. So I've finished half the question now. I've got c is 4 and I need to know what d is. So I need to write down one of the original formulas and substitute in c is 4. Now I could use the first original equation if I wanted to, but it might be easier to use the second one. And I've done that because it's got a plus 3d in. So I'll be dealing with pluses instead of the minus d in the original one. Write down the original equation, 2c plus 3d is 11. Now I know that c is 4, So 2 times c is 2 times 4, which is 8. And we've got 8 plus 3d is 11. This is just a normal equation, so take away 8 from both sides. And I end up with 3d is 3. And if I want to know what 1d is, divide both sides by 3. 3 divided by 3 is d, and 3 divided by 3 is 1. So my answer is d is 1. So my final answer for the entire question is c is 4, d is 1. And these are the only answers that will work on both original equations simultaneously. Three e minus 4f is 7, 2e minus f is 8. So again, none of the numbers are the same. I've got 3e on top and 2e on the bottom. Minus 4f on top and minus 1f on the bottom. I need to multiply one of the equations so that the numbers are the same. I'm going to choose to do this for f, but I could have chosen to do it for e as well. So, to make the bottom minus 4f, I need to multiply the whole thing by 4. Write down the original equation. We're going to multiply the second equation by 4. 2e times 4 is 80. Minus 1f times 4 is minus 4f. And 8 times 4 is 32. So now I've got two more equations, but now I've got minus 4f on top and minus 4f on the bottom. Because these are the same, I'm going to take away. 3e take away 80 is minus 5e. Minus 4f minus minus 4f is nothing. Remember that doing minus minus 4f is the same as adding 4f. 7 take away 32 is minus 25. Now if I want to know what 1e is, I divide both sides by minus 5. Minus 5e divided by minus 5 is 1e. Minus 25 divided by minus 5 is plus 5. So e is 5. But I also need to find out what f is equal to. So again, I need to rewrite one of the original equations. It doesn't really matter which one this time. I'm going to choose the second one. And I'm going to substitute in e is 5 into it. And that way I'll find out what f is as well. So, rewrite the original equation, 2e minus f equals 8. I know that e is 5. 2 times 5 is 10. This is just a normal equation, so I'm going to take away 10 from both sides. 10 minus 10 is nothing. The minus f is still there. 8 minus 10 is minus 2. So I've got minus 1f is minus 2. Divide both sides by minus 1. And I end up with f is 2. So my final answer for this question is e is 5, f is 2. And these are the only two numbers that will work on both equations simultaneously. Simultaneous equations are equations where we find out what two letters are equal to.